So I'm gonna stream right now just because it has been a long time since I haven't streamed, and I think I'm gonna spend 1 hour here. Uh, I don't wanna spend a lot of time because I'm working on the Buildspace stuff, and in order to do the things that I'm doing, I need to watch a bunch of tutorials and go back to a bunch of courses that I did, and it's just not good, I think, to try to do this on stream. For now, maybe in the near future, once I get done. Right now, I'm building the backend. I think I can show here. I started everything again from scratch. So I was trying to make it work with TypeScript because I was gonna use Tailwind CSS for doing this navbar here. And then I was trying to make it work with React on the other project. But then I spent a bunch of time trying to figure things out and the dependencies and stuff like that. And it just wasn't working. I could make work, but it was just too much. It felt like a duct tape solution, the way that I figure out. And because of that, and because I pretty much didn't have anything new, and I gave up on the idea of the NFT marketplace, I decided to scratch the whole project and start from scratch, which is kind of funny because in the beginning, the reason why I decided to do the NFT marketplace was because I didn't want to not have anything to show for in the last day. But then as I did the thing, I realized that it probably doesn't matter because even if I fail, it's better to fail trying to do something that I really want to do and I believe in and it is aligned with my longer vision than to succeed doing something that I don't like. And that's why I decided to take the risk and just do this thing from the beginning. But now it's obviously a lot harder because I have no idea how long it's gonna take me to do each particular thing, and it's already taking me a lot more time than I thought to build. Part of the reason why is because I really think it's boring to do this navbar stuff here, which is the step that I'm on right now. I'm trying to make navbar, the drop down for this navbar, and I'm gonna use the same. I'm pretty much copying the stuff from Buildspace because I think their navbar is really cool and it looks very professional. So I'm gonna try to do it like exactly like this. But the biggest challenge with this is that there are several different designs that I can think of, and I watched a bunch of videos and read a bunch of stuff, try a bunch of different methods, but it's really hard to figure out which one to choose because this is the most important component, I feel like, on the app because it's gonna link to all the other pages and all the other pages are gonna show very complex data, I think. Maybe it's not so complex, these ones, but in the future, if I'm gonna expand on this, I plan to integrate machine learning and then do very complex data analysis involve a bunch of stuff and then create user interface and all of that. So if I choose the design for the navbar, which is not really nice, then later on I'm gonna find out and I'm gonna have to change everything again so it fits, and I really don't wanna do that. But what I'm thinking about doing here now is to make it conditionally based on state, the navbar based on the hover state. And if I don't hover, it shows an empty div, and if I hover, I put it on another component, and then inside of the component, I put all the logic for the navbar, and then I just change the props that I pass for each tab. But the problem with this approach is that I can't figure out how to design this component in a way that just by passing different props, I can, because the issue is all of them have different lengths depending on the thing they have. So I feel like that's not probably the best solution. And the other way that I was thinking about was doing exactly like this, but putting the whole component here. But the issue with that way is that the component I got this from the Buildspace website, and it's massive. There's so much stuff here to make this little menu here, this little drop down. And I also saw different tutorials talking about the design and how complicated this actually is, even though it seems easy. And part of the reason why it takes me so long is because I also don't like doing this. I think it's not that I don't like, it's just that I'm much more interested on the data analysis part and figuring out the stuff on the blockchain. I'm very curious about that and how I can use the data to make conclusions about people and market and the market economy and stuff like that. And then now I stopped doing this with the Django. I just begin the Django setup, and I'm watching the tutorials again and the courses again that I did about this to try to understand better. I found a really good free code camp course that I think I'm gonna watch, but it's 18 hours, and then I have probably another 24 hours or more for UX design, UI design courses from Scrimba that I wanna do. And all of this stuff is gonna take a massive amount of time, I think. And then I'm doing this stuff, I'm building the site as I go through the courses. That's why it's not good to... some of these courses I paid for as well, and so I can't really show on stream. But I was watching this one. Unfortunately, it didn't... Okay, got... I really like this player, by the way, as well. It allows you to up the speed. If you press X or C, it increases or decreases the speed, and it goes up to whatever amount I think you want. So it's really good because as I get used to watching videos faster and faster, I feel like I can increase to 3x speed and I can still understand everything. And the downside of this is that it gets a little bit annoying when I'm watching on YouTube and I can only put on 2x because it feels really slow. But yeah, my plan now is to finish doing this backend for the authentication, and I also think I'm gonna watch another or do another course if I have trouble trying to do this, following the course that I already did and following this one. I'm gonna try to do another one and then just see how I should integrate the Django with the next, and then deploy. And then after that, I think it will work on the navbar. And then after I work on the navbar, then should be the interesting part, which is figuring out how to connect the data from the blockchain to the database with Django, and then displaying this data on the front end. I think I'm gonna use... I'm not sure actually what I'm gonna do, because it's probably easier to get the data from the blockchain and put it on the data frame, on a pandas data frame, and then translate that pandas data frame into the database model and do the workflow like that. But I think it might be more efficient to get directly from the chain and then put it on Django, but that's gonna be really hard, I think, because I don't understand really well how the models work in the Django part. I understand that you have to create these classes here, and then you put the whatever you're gonna use here, and then you associate based on relations on key. But I really don't know how it's gonna be because I have to create a script that gets the data. Or maybe actually, maybe I think I know actually how to do. Because I was watching I was watching the tutorial yesterday and I wrote this down, which is pretty much you pass a list of dictionaries here in these methods, and then by doing this is available on the models, I think. So I can probably create a script inside of this file, and then with the script get the data from the blockchain and put it on JSON format or something like that, and then pass it to this method on this file, import here and pass it here. But the thing that is going to be difficult as well is to figure out how the frequency that I'm going to update the database, because there's so far millions of lines in the pandas data frame from the blocks that I got, and I'm only on the 8 million block. And there's around 15 to 16 million blocks already in the blockchain. I'm also thinking about getting more hardware and creating my own node eventually as well, because that's going to be a lot better. both in case I want to mine in the future, but not only because of that, but because I think it's going to be better to get more information if I have my own node instead of doing like this. So I think that's everything that I had to talk about. Oh, and integrating the wallet was a little bit complicated as well, but luckily I already had most of it. I went through most of it in the other project. And so far I've been liking Next.js a lot more than React. It seems a lot better. And I think the difference between Next and React is that Next loads up everything on the server side and then only sends to the client after everything is loaded up. But I don't understand really well yet. But I think it's something like that. And it has a lot more updates and small little things that make it a lot better than React. So I think I'm gonna stuck for next projects with Next, if I do next projects, because I might decide to just go really hard on this one and incorporate a bunch of things, which is actually sounds more exciting to me. So I think now I'm gonna try to read these articles for the remaining amount of time, and then I'm gonna close the stream and continue to work. Oh yeah, I didn't finish all the Eternal challenges. I did a couple of them, but then I was having some problems with Remix, and I decided to, because it's too much time, I decided to just watch the videos of people doing. And then I stopped. I didn't stop. I saved the video for this one because I thought this challenge was really interesting, and it was related to the articles of OpenZeppelin that I read some time ago. And then this guy, shout out to him. He recommended these articles here. I think it's on the description of this video. And also I forked two repos with information from the blockchain, the OP codes and other repo that I don't remember really well, but it was useful stuff. So I'm thinking that maybe after I finish the Django and maybe even the navbar, I start streaming again and trying to build on stream. But I'm not really sure yet. And I also find out about a library called Streamlit. And this allows you to display machine learning models and seems very easy to use from the tutorials I saw. And yeah. And also, I really like Tailwind CSS. After I did a course on it, I was trying to use it and understand it. Then I did a course on Scrimba to understand more how it works. And I think that the main difference between, so far from my experience, from Bootstrap and Tailwind CSS is that Tailwind CSS you can customize the sizes and the colors, and Bootstrap it comes with pre-default ones that kind of look like trash, and Tailwind CSS is much better and much easier to style things, and I really like it so far. Obviously I'm not that good at it because I just started using it, but it feels like I'm gonna use that a lot. I'm probably gonna use it on all of my projects. The only downside is the setup, which is a little bit annoying, but if you're starting from scratch, then it's easy because you can just get the documentation from Next.js, and they have a way to start where you specify that you're gonna use Tailwind CSS, and then it sets up everything for you. So that part is easy, but if you're gonna do it from scratch, it's a little bit annoying. But I'm considering whether or not to use this stuff when it comes to the point where I'm gonna display the data on the front end from the back end. And also, obviously, I'm gonna have to use the data I have here, the data frames, and I'm gonna see when it comes the time to explore the information on the blockchain. I'm gonna see if I can use the data that I already have to make new searches, and also think about algorithms and patterns and stuff like that. And that should be, for me, the most interesting part. And I'm gonna have to use this data, which doesn't have all the blocks, but there's nothing I can do about it because I think the maximum amount of blocks that I can get in a day if I run for 24 hours is 300,000 or something like that. And there's 16 million blocks, so there's not enough time to get all of them. And I'm not gonna be running 24/7 because it's not that good. But I think it doesn't matter that much as long as I can display something and understand how everything works. Then later on I can figure out how to improve it, especially if I create my own node. And for some reason OBS disconnected, but it seems like it's still recording, so I'm gonna keep going. So let me read this. This is related to this challenge here, magic number. For some reason the level here is different, but yeah. Turn on level 19 magic number walkthrough. How to deploy contracts using raw assembly OP codes. This is an in-depth series around saplings, themes, smart contract security puzzles. Okay. I think this part I found interesting. Contract creation disassembled. It's related to the articles that I already read, but it's still interesting. An account sends a create contract transaction. Construct and so on. The EVM compiles contract code into bytecode. Bytecode is loaded onto the stack. EVM initializes contract. Yeah, so the contract is separated, I think, in two parts. One is the creation time and the other is the runtime. And in the creation time is the constructor, where it's going to initialize the contract. And I think the function, I don't remember really well, but there's something that points to the functions, I think. And that thing is initialized on the creation. And then on runtime, I have the actual functions. But I don't remember really well. What happens during contract creation? We call the duration contract initialization. The following happens. First, the user or contract sends a transaction to the Ethereum network. This transaction contains data but no recipient address. This format indicates to the EVM that is a contract creation, not a regular send call transaction. Second, the EVM compiles the contract code in Solidity, a high-level human-readable language, into bytecode, a low-level machine-readable language. This bytecode directly translates into OP codes which are executed in a single call stack. Important to note, contract creation bytecode contains both initialization code and the contract's actual runtime code. Okay. So it contains both. Concatenated in sequential order. During contract creation, the EVM only executes the initialization code until it reaches the first stop or rerun instruction in the stack. During this stage, the contract constructor's function is run and the contract has an address. After this initialization code is run, only the runtime code remains on the stack. These OP codes are then copied into memory and returned to the EVM. Finally, the EVM stores this returned surplus code in the state storage. In association with the new contract address, this is the runtime code that will be executed by the stack and all future calls to the new contract. Pretty simply, to solve this level, you need two sets of OP codes. Initialization OP codes should be run immediately by the EVM to create your contract and store your future runtime OP codes, and runtime OP codes should contain the actual execution logic you want. This is the main part of your code that should return 0x, 0x42 and be under 10 OP codes. At this point, to independently solve this level, you can read in depth about OP codes and smart contract deconstruction from the author of this Ethernet level. For a bit more guidance, let's press on. And one thing I think I'm going to investigate as well is how the RPCs get the data from the chain, because I think what they do is they are miners and then they use the information from the mining it synchronizes the blocks first, and then it evaluates transactions on the mempool, and then they probably use that to all the transactions and the validations and the mempool to create the RPC to send events to whoever calls the API. I think that's how it works. But there might be differences as well. I'm not really sure. And I think that's probably a good thing to investigate, because I'm obviously, the whole point of what I'm doing is analyzing the data on the blockchain, so it's going to be important to know what kinds of data I can get from the RPC, and if there's any difference about the data that I can get with my own node. And I suspect that there are probably differences. And I'm also going to see if I can get all the OP codes as well, and search by OP codes and stuff like that, instead of searching by the methods, the normal methods. Because I think that will allow me to get a lot more patterns from the chain. Also, another thing that I will have to study is the integration of Polygon in Ethereum, that I don't understand really well. But worst case scenario, I just do it for Ethereum, and then I think about this stuff later. So that's not a big deal, I think. The biggest thing that I'm uncertain about is how long it's going to take for me to figure out how to display the data, and how hard it's going to be to create the pages, because I haven't thought about the way that I want to display everything, and how it's going to connect with the backend. I think that's the hardest part to figure out. Fire up Truffle console with Ropsten or a preferred setup to be able to directly deploy bytecode to the AVM, and open up this bytecode opcode conversion chart for easy reference. Runtime opcodes. Part 1. First, let's figure out the runtime code logic. The level constrains you to only 10 opcodes. Luckily, it doesn't take more than that to return a simple 0x32. Returning values is handled by the return opcode, which takes in 2 arguments. P, the position where your value is stored in memory, i.e. 0x0, 0x40, 0x50. Let's arbitrarily pick the 80 slot. S, the size of your stored data. Recall your value is 32 bytes long, or 0x20 in hex. Yeah, each value in the stack is 32 bytes. And there are some tricks to optimize for gas if you put on the same stack. If you make the data fit on 32 bytes instead of having it occupy less bytes. And there's some difference in methods from what I remember. Depending which one you use, you save more gas. Recall that Ethereum memory looks like this as efficient position references. But this means before you can return a value, first you have to store it in memory. First, store your 42 value in memory with mstore pv, where p is position and v is the value in hexadecimal. The value is 42, memory is 80. Then you can return the 42 value. Turn F3. This resulting opcode sequence should be this. The runtime opcode is exactly 10 opcodes and 10 bytes long. Initialization opcodes, part 2. Now let's create a contract initialization opcodes. These opcodes need to replicate your runtime opcodes to memory before returning them to the EVM. Recall that the EVM will then automatically save the runtime sequence to the blockchain. You won't have to handle this last part. Copying code from one place to another is handled by the opcode called copy, which takes in 3 arguments. T, the destination position of the code in memory. Let's arbitrarily save the code to 0 position. F, the current position of the runtime opcodes in reference to the entire bytecode. Remember that F starts after initialization opcodes, and what a chicken and egg problem. This value is currently unknown to you. S, size of the code in bytes. Recall that this is 10 bytes long. First, copy your runtime opcodes into memory and add a placeholder for F, as it is currently unknown. The light is changing here, it's kind of hard to read. Then return your in-memory runtime opcodes to the EVM. Notice that in total, your initialization opcodes take up 12 bytes or 0x0c spaces. This means your runtime opcodes will start at index 0x0c, where F is now known to be 0x0c. The final sequence is thus this one. where the first 12 bytes are initialization opcodes and the subsequent 10 bytes are your runtime opcodes. Truffle console, create your contract with the following commands. So, address and bytecode. Interesting. So you can create by separating each instruction and putting in one bytecode. If I understand correctly what's going on here. Yeah, pretty much, because it's kind of like the same thing, I think. Then using the ABI and passing. Because they're actually doing the same thing, but in a lower level, I think. Look up the newly created contract address from the return transaction hash. You can do this via Etherscan or via get transaction receipt. In the internal web console, simply input the following to pass the level. To learn more solidity, check out solidity cons to learn more solidity to test during development. Recommended, start here. I'm gonna close this. Wow, so I still have 34 minutes. I think I can finish the other one. Hopefully it doesn't take me a long time to figure out how to set up the Django with the front end and deploy that and finish the navbar. I'm very anxious to start studying about the Solidity stuff and getting the information from Chain. And also trying to build machine learning models based on it. I think I'm not gonna do this one. I'm gonna focus on one thing at a time, so I don't get too. Because I start opening up all these tabs here. Naturally, as I learn stuff or try to figure out stuff, and then starts getting too scattered again. Solidity, bytecodes, and opcode basics. I don't know why I have Remix open as well. Close this. As we go deeper into writing smart contracts, we will come across terminologies like push one, SS store, call value. What are they and should we even care about them? To know these commands, we have to go deeper into the Ethereum virtual machine. I was surprised there were few resources on this subject when I googled around. Oh, actually, I might read the yellow paper as well at some point. Maybe I'll do that on stream just to have the vlog of myself learning these things. But I'm not really sure. It's gonna depend on how long each thing takes, I think. If I get to the point where I have a few pages and I have at least something to show, then I think I'm gonna do that to get more advanced stuff. To know these commands, we have to go deeper into the Ethereum virtual machine. I was surprised there were very few resources on this subject. Perhaps they were too technical. I try to explain some EVM basics as simple as I can. Like many other popular programming languages, Solidity is a high-level programming language. We understand it, but the machine doesn't. When we install an Ethereum client such as GIF, it also comes with the Ethereum virtual machine, a lightweight operating system that is especially created to run smart contracts. When we compile the Solidity code using the Sock compiler, it will translate our code into bytecode, something only the EVM can understand. Oh, interesting. So the operating system comes with the GIF client, which I didn't know. If we run this code in the Remix browser and click on the contract details, we see lots of information. So runtime bytecode, opcodes, assembly. In this case, the decompiled code is this. These long values are a hexadecimal representation of the final contract, also known as bytecode. Under the Web3 deploy section of the Remix browser, we see. Okay. In simple terms, it means that when we deploy the contract, we simply deploy the hexadecimal under the data field with the recommended gas of this number here. We have to start thinking hexadecimal if you want to talk to the AVM. Ever wonder why there is 0x in front of your wallet or transaction address? That's right, anything beginning with 0x simply means the value is in hexadecimal format. Having 0x in front of a hexadecimal is not compulsory because the AVM will treat any value as hexadecimal irregardless. We also see the operation code, aka OP code. Also, another thing that I'm thinking about is why haven't anyone built something to translate these hexadecimals into something else that is more simple so that people can have in the front end? Because I think oftentimes those large numbers are really hard for people to think about. Especially when copying to other places, even though you can just click to copy, but if you're gonna send to someone a wallet, yeah, but then, yeah, I don't know. Because if you're gonna translate into something more simple, you would need to be something unique that you can, yeah, so it's probably a lot harder. We also see the operation code, aka opcode. These opcodes are the low-level human-readable instructions of the program. All opcodes have their hexadecimal counterparts, e.g. MS star 0x52, SS star 0x55. Python, GitHub, Ripple, and the other Ethereum yellow paper have some good reference for all the Solidity opcodes and their hexadecimal values. The AVM is also a stack machine. To explain simply, imagine stacking up slices of bread in a microwave. That slice you put the first. Okay. Normal arithmetic, we write our equation this way. So it's pretty much a stack. It works in the stack format. Orientation is moving short-lived temporary values to and from a push-down stack. Stack is used. Stack machines extend push-down automata with additional load star operations or multiple stacks and hence are Turing complete. Stack machine introduction was... I'm not gonna read this stuff now. The stack machine, it works in LIFO principle, that's in first out. It means put shoe in the stack first, followed by another shoe, then followed by a multiplication action. The result is 4 sitting on top of the stack, now add a number 10 on top of 4, and eventually add the two numbers together. The final value of the stack becomes 14. This type of arithmetic is called postfix notation or reverse Polish notation. I'm not sure if it's a stack machine because it makes sense, because it's the same structure for validating the blocks. Not the same structure, but it's similar, which is a Merkle tree, I think. And then stack can create these kinds of tree structures on the execution, but I'm not sure if it's related or it doesn't make any sense. The act of putting data in the stack is called the push interaction, and the act of removing data from the stack is called the pop instruction. It's obvious that the most common opcode we see in our example above is push 1, which means putting 1 byte of data into the stack. It means putting a 1 byte value of 0.60 in the stack. Coincidentally, the hexadecimal value for push 1 happens to be 0.60 as well. Removing the non-compulsory 0x, we could write this logic in bytecode as 6060. Let us go a bit further. Looking at our favorite Ethereum opcode chart, again we see the AMS star 52 takes in 2 inputs and produces no output. The opcodes above mean push 60 into the stack, push 40. AMS star allocates 60 of memory space and moves to the 40 position. I don't understand this very well. Resulting bytecode is this. Allocate 60. Allocate. Oh, because they're on the stack, I think. I bet. I'm not sure. Yeah, because it takes 2 inputs. So the first one is where it's gonna be moved to, and the last one is the amount, I think. In fact, we always see this magic number in the beginning of any Solidity bytecode because it's how the smart contract bootstraps. Bootstrap. Interesting. 60, 60, 64, 52. To further complicate the matter, 40 or 60 cannot be interpreted as the real number 40 or 60. Since they are hexadecimal, 40 actually equals to 64, and 60 equals to 96 in decimal. In short, what push 1 60 push 1 40 is doing is allocating 96 bytes of memory and moving the pointer to the beginning of the 64th byte. We now have 64 bytes for scratch space and 32 bytes for temporary memory storage. In the EVM, there are 3 places to store data. Firstly, in the stack, just use the push opcode to store data there, as per the example above. Secondly, in the memory RAM, where we use the mstore opcode, and lastly, in the disk storage, where we use ss-store to store the data. I think I'm gonna take a picture of this, because so far has been the cleanest explanation I think I've seen. Because I've looked at the videos explaining the difference between qual data, memory, and some other special keyword storage, I think, for allocating different parts of the smart contract on the EVM, but I think this feels a lot easier for me. Maybe I should just put... I'll think about different ways to name this later. So you have push that pushes items to the stack. I have memory that's mstore, and then you have ss-store that's for disk storage. The gas required to store data to storage is the most expensive, and storing data to stack is the cheapest. Yeah, I think that's kind of intuitive, because if we're gonna store forever, then it's obviously gonna take more. We're gonna have to spend more. As required to store data, to storage is the most expensive. Yeah, so to store on the disk is the most expensive, then the mstore is the second one that is most expensive, and then the stack is the cheapest. Assembly language. It is also possible to write the whole smart contract using opcodes. That's where the Solidity assembly language comes in. It might be a lot harder to understand, but could be useful if you want to save gas and do things that cannot be done by Solidity. Summary, we have only covered the basics of bytecodes and a few opcodes. There are so many opcodes not yet discussed, but you get the idea. Back to the original question of whether we should even bother learning Solidity opcodes, possibly yes and no. You don't need to know opcodes to start writing smart contracts, and it adds to the learning curve. On the other hand, the EVM error handling is still very primitive. At the time of writing, it's handy to look at opcodes when things go wrong. At the end of the day, there's no harm learning more. Oh. Yeah, so I think I'm gonna stop here. Another video I was watching for the navbar. Even though there's a lot of time, but my main priority now is to finish the... I'm gonna try to finish the jungle first, and then deploy to... I don't know where. I saw that Hiroko is possible to deploy, but I already have my portfolio there, so I'm not sure if I'm gonna be able to deploy another site for the same account. So I'm probably gonna try to separate, then if I can't, use Hiroko as a last resort. And then, yeah. So figure out the jungle, then deploy, then think about the navbar. And then at the navbar, I might start streaming again and try to figure out as I stream how to do the drop downs. But if not, then probably after I'm done with that and I start building the pages, I might start streaming again. And for the part where I'm gonna try to integrate the blockchain information with the front end. And it might take me a lot of time to do that because I have to watch all the other courses. I think, like I said before, it's gonna take me, I think total amount is probably 24 hours of courses, but I'm gonna try to do them at 2x speed or more. So it might be faster, but I'm also gonna have to work on all of this stuff as I watch the courses. So it might take me a few days to get everything done. Hopefully not. Hopefully it takes me less time. But yeah. And then once I'm done with all that, I'm gonna go back to streaming, I think, frequently and try to do as much as I can of this project on stream until the demo day, which I think is on a little bit less than 1 month from now. I think it's day 5, 6 or something like that. So till next time.